Hello and welcome one and all. Today we will continue with data analysis using SQL. In the previous session, we focused on customer analysis. Today we will focus on product sales analysis. This helps us drive continued improvement and growth. And when we analyze sales data and use it effectively, the entire team is better up for success. Analyzing product sales data is crucial, especially when it comes to improving your product's performance and tracking the projection for a given product. It helps us determine the top performing products or features, as well as the ones that are lagging behind. It is crucial to spend time in your numbers. It allows us to regularly find ways to enhance our product sales. Also, it leads to more accurate forecasting, which means better suited planning and goals for our products. Let's go ahead and carry out this analysis using SQL with AdventureWorks. We will go ahead and define few business questions to help us analyze the product's data. We'll answer the following questions. First, the total sales by products. Based on this, we can look at our best performing products, and we can see what are the top 10 products with lowest production cost. And then we'll go over difference in sales amount among product categories. And if we have time, we'll go over distribution of sales amount by product, by year and month. During this exercise, we'll focus on the products tables and sales fact table. Let's create a database diagram to highlight the tables we will be working with. So we can right click on create diagram, and here we can select the tables. So we will select the product tables that starts with dim product, category and subcategory. And I'll also add the fact internet sales table. We can go ahead and click on add, and the tables are added to the diagram and along with the relationships. So if we hover over the relationship, it tells us how a table is related from one to another. We can see that we have a snowflake schema. So our product links to product subcategory, and subcategory links to category. And then the product table links to the fact table, which is the fact internet sales. We can go ahead and explore these tables individually, but our product related data is in the product tables. These are called dimensions. The sales metric relating to these products are in the fact internet sales table, and this is a fact table. So during our exercise, we'll be joining these tables to get the answers for our business questions. Let's go ahead and answer the first question with the help of SQL. I have Management Studio open. I'll go ahead and open a new query window from the top ribbon. And based on the feedback from the previous video on SQL, I have increased the font size here. So do let me know in the comments below if the font size is good. Also, I'll make the complete SQL queries available on GitHub. Link will be in the description below. So our first question is to display the total sales by products. This will help us determine how much sales each product is generating. So let's select from the product table first. So we'll go ahead and select top 10 rows from dim product to see what this table contains. We don't want to select everything from a large table, as we would block anyone querying this table. So always use a where clause to filter your query first before running it against a large table. Or we can take a sample with the top keyword. This is our products table, and in this table, the main columns that we're after is the product name, which is called the English product name. And we'll make a note of the primary key on this table, which is the product key. This is the column that we will use to join to fact internet sales. Let's join the product table to the fact internet sales to get the sales amount. So we'll utilize the inner join and then the fact internet sales table. Let's go ahead and alias these tables so we don't have to write the full name every time we reference it in our code. So the dim product will be P, and the fact internet sales is aliased as F. After the F, we use the on keyword and then specify the columns we want to join on, which in this case is the product key. In the select, we specify the columns we need. So from the product, we will take English product name, and we can prefix it with P to make it explicit that we are selecting this from the products table. and sales amount we can prefix it with F. We'll go ahead and rename these columns with the help of as keyword. So the English product name becomes product underscore name and sales amount as sales underscore amount. If we run this query, it returns every single transaction from the database. And it returns 60,000 plus rows. To get the total sales amount by a product, we will use an aggregate function, sum. An aggregate function performs a calculation on a set of values and returns a single value. When we use an aggregate function, we have to use a group by. The group by statement groups rows that have the same value in the product name rows. For example, we will get one row for all-purpose bike stand product, along with the sales amount value. So whatever column we have in the select where we do not apply the aggregate function, those columns must be present in the group by. So it'll be the English product name, and we use the actual column, not the alias in the group by. Let's go ahead and run the query again. We get 130 rows now, as opposed to 60,000 rows. Okay, so this is the answer to our first question. So this gives us the sales by product. And to answer the next question, we can answer it with this query with few tweaks. To get the top n products with highest sales amount, we can use the top 10 clause. Along with this, we will use the order by clause. We will order this result set by sales amount in descending order. Keyword for descending is DESC. Let's go ahead and run our query, and we get the top 10 products with highest sales amount. The next question is quite similar to this, where we want to display the top 10 products with lowest production cost. So we can keep this query open and simply swap the sales amount column with total product cost. In this scenario, we want the products with lowest cost, so we will order the query by total product cost in ascending order with keyword ASC. So this gives us top 10 products with lowest production cost. For the next question, we move away from product to categories. This is a high-level grouping of products. So multiple product will roll into one single category. So we will get a high-level overview of the sales amount broken out by categories. If you're making a visual in BI tool, then it'll be a perfect candidate to put in a bar chart or in a pie chart. Anyways, let's add the product subcategory table. You must be saying, hold on, we are trying to display the sales against product category, then why are we adding the subcategory table? It is a valid question. However, the product table joins to the product subcategory, and the subcategory table joins to the category. So we join the product table on product subcategory key, and then we'll bring in the product category table, and we'll join this to the subcategory table on the product category key. We already have the fact internet sales table in the mix, so we'll bring the sales amount column back in the query, and let's go ahead and remove the top 10 clause. Also, let's fix the order by and make it descending. So let's go ahead and fix the select. We'll need to select the product category name from product category, and let's go ahead and fix alias as well. I think we need to fix the group by as well. So I'll bring the English product category name down to the group by and fix the alias, and we can run the query. Okay, one more thing. Let's go ahead and fix the sales amount alias. It should be total underscore sales. So let's go ahead and run this query, and this displays sales by category. We can see that the bike category has the highest sales as compared to other categories. We can also display the number at subcategory level, but I'll leave that for you. I think I'll stop here. In the next session, we will include the date metrics in the mix to display sales across months, quarters, and years. And I will also model this data in Power BI so we can visualize this data as we go along. This is all for now. Like, share, and subscribe. Take care, and I'll see you in the next video.